Well, hi, everybody. Welcome. Welcome to reInvent. What a great looking crowd. This is a really nice space for a presentation today, so thanks for joining me. This is ARC208, Hybrid Architectures, Bridging the Gap to the Cloud. So my name is Jamie Butler. I lead our solutions architecture team for US state and local government. Prior to joining AWS about 2 years ago, I spent about 15 years in higher education in a number of IT leadership roles. So I wanted to give you just a little bit of overview of what we're going to talk about today and what to expect about this session. So this is a 200-level session. So the expectation is that you're very familiar with the cloud and some of AWS's availability zones and regions. But we're going to talk about some of the services that are really relevant to hybrid. The expectation is that you're not super deep, and this discussion is not going to go very deep technically. So hopefully that's the right session you're looking for today. We are not going to be talking about the VMware announcement that we made recently. That's a different session, so hopefully everyone's in the right place. Today we're going to cover the AWS services that really help you to achieve hybrid cloud, as well as a customer use case for hybrid. And then I'm going to show a couple of demos along the way to give you a good feel of how the AWS environment works. So someone told me once that it's best to start a presentation with words from somebody who's much smarter than you. In this case, I chose Werner. The quote here, I think, is really salient because it talks about how AWS isn't building an all-or-nothing environment, but rather we're empowering customers to have choice. So if you have an investment in on-prem infrastructure that you want to continue to leverage, but you also want to take advantage of the scalability and the cost benefits of the cloud, we have a lot of services that will help you achieve both. So I want to start by talking about a customer's journey to AWS. They approached me and said, look, we really want to take advantage of AWS for the flexibility of starting new resources, for the scalability of growing into services that we need, as well as some of the cost benefits. We also want to empower our customers, our end users, to have flexibility with how they access our services, whether that's from our own network or if that's from their home using their own device, BYOD. So this particular customer is a large public sector customer. Very much like most of you today, there's a central IT team that handles a lot of the core infrastructure, networking, facilities, servers. And then there's IT departments within the business units and departments that are really building and maintaining the line of business IT systems. So we're working with this customer, and we said, okay, let's focus down on one application, because there's a lot of moving parts with a very large organization. And so it's best to start small, build some momentum, build some competency and some excitement, and then get bigger. So this is what the customer's environment looked like, at least this one portion of the application we were talking about. It was Active Directory that maintained all of the user identity. There was a file server for maintaining all of the files, and then a number of Windows desktops that were connecting to that Windows file server. So this is pretty standard, pretty simple workload. But what it does is it shows how simple something can be and how we can take that and translate it to the cloud in a very easy but very robust way. So when I start talking with customers who have a lot of moving parts and a lot of workloads, typically we say, okay, let's take a step and talk about identity. Identity is important because we don't want to have a proliferation of different identity stores, different users. It's very difficult to manage. And so AWS provides a lot of services to help manage identity in the cloud. So let's start that conversation with the customer. We talk about IAM, which is our Identity and Access Management Service. This service provides fine-grained control of all of your cloud-based resources. So if you have a group of users that are your system administrators, you can provide roles and policies that allow those system administrators to manage servers. And then you can provide other policies to allow your network administrators to manage the network and infrastructure. And the two can't change each other's work. And so you can create that separation of duties within your cloud environment, just like you have on-premise today. Not only that, but we can take identity access management and integrate that with your on-premises Active Directory. So if you want to take that corporate directory, that identity store you already have, you can leverage those user identities, passwords, and use that account to access your resources in AWS. We also provide the ability to use multi-factor authentication. So for those users who have the ability to create and destroy resources inside of AWS, it's often a good idea to lock those down to make sure that you know who those users are, and you use two-factor authentication to do that. And that's supported inside of IAM. IAM also supports federation. So if you're using an ADFS server today or another SAML provider, or if you're leveraging your identity store from Amazon, Facebook, Google, or any other OpenID provider, you can integrate those identities with IAM so that, again, you have that single source of truth across both platforms. Another great service that AWS provides is the directory service. So this comes in 3 flavors. There's Microsoft Active Directory, which is a fully managed Active Directory environment from Windows, Microsoft. We also have Simple AD, which is a Microsoft-compatible directory leveraging Samba. And then we have the AD connector, which is a proxy to your on-premises Active Directory. All 3 of these are delivered as a managed service, so you don't have to worry about patching your environment or doing backups. All of that's handled for you. The value of leveraging the directory service, in addition to being simple, is that it allows you to join servers or instances running inside of AWS to your directory very seamlessly. It also allows you to do single sign-on to your AWS console and other applications within the cloud. So what I wanted to do next was show you a demo of how easy it is to create a managed Microsoft Active Directory inside of AWS. And I'm going to do a demo. We were going to do a live demo, but there's something always goes wrong with technology. Usually it's my fault, so I will own that. But today we did a recording to show you exactly what this looks like. The other benefit of the recording is that I can fast forward some of the wait time, because as you're spinning up resources in the cloud, sometimes it takes 5 or 10 minutes for a resource to get created and configured. All that happens in the background, so I'm going to be able to scrub out that extra time today. So this demo is going to go through creating a Microsoft Active Directory, then configuring that Active Directory to do sign-on directly to the AWS console. So I usually show customers this because it really demonstrates the power of how simple and easy things can be within AWS. So first, what I'm going to do here is click on Microsoft AD, one of the 3 options, and then I'm going to define my Active Directory domain name. This is the fully qualified domain name. reInvent demo is mine for today. After I enter the NetBIOS name, you'll see that I have a default admin user of admin, and I need to create the password for that. You can also see that there's some VPC details. That's a lot of the underlying networking that we're going to talk about later. But we do have the option of where to create this directory. For now, I'm going to choose the defaults. You can see there's a warning right there that lets you know there may be some charges for this. We try to let you know ahead of time that there might be charges so that you don't get an unexpected bill. So now you can see that this resource is being created in the background, and it typically takes about 20 to 25 minutes for that resource to be fully stood up and configured. Now, through the power of television, we're going to fast forward through that, and you're going to see that the directory was created and is now active. So there are the details for the directory, and now I can connect into the directory, and I need to create an access URL. That access URL is my unique URL name to get to my AWS resources for this directory. So first we create that, and then it updates all the DNS records. And after that, we need to go create and configure the roles and the users that will assume those roles for giving access permissions into the console. So first, we'll enable the directory for console access, and then we're going to create a role. Now, again, earlier I said you can do fine-grained access, so you can create customized roles and permissions. For today, in this demo, I'm just going to choose one of the default templates, but know that you can make this very granular. As you can see, there's a couple of pre-built, pre-canned options. I'm going to choose power user because, after all, this is my admin user. So next, I have to search for either an Active Directory group or an Active Directory user that I want to associate with this role and the permissions that they'll have in AWS. So I've selected my admin user. I'm going to assign them to the role. And now I'll be able to use the credentials from my admin user running in Active Directory to authenticate to the AWS console. So next, I need to grab the sign-in URL from the directory, and then I'll right-click on that and open it up in a new tab. And now you can see that I can log in with my admin user that I created for AD and the password. So that's as simple and easy as it is to create a fully managed Active Directory environment inside of AWS and then begin leveraging those users to sign into the console. So if you wanted to leverage that as your single source of truth for all of your applications running in the cloud, it's that easy. So now that we've talked through identity and the customer really understands how to manage their identity in both their on-premise and in the cloud, we said, okay, before we do anything else, let's make sure we back up our data. Do you have a good backup of your data before we start making any architectural changes? And are you confident that you have access to that? Is it in a tape that's stored halfway around the world? Is that on-prem? Where is that? And so we first said, okay, let's make sure we have a good backup strategy for that data that we have access to today. So we first started talking about some of the services that really help that customer do backups. When you think of backups to AWS, the first thing that comes to mind is object-based storage. It's very inexpensive and extremely durable. We have 3 tiers of storage. We have our S3, or simple storage service. We have S3 infrequent access, and then we have Amazon Glacier. All 3 are designed for 11 nines of durability, which is a fancy way of saying if you took 10,000 objects and put them into the store, you may lose 1 object every 10 million years or so. So this is a very durable place to put your data. You can rest assured that when you put your data into the service, you can get it back out again, which is really the point. In addition to the 3 tiers, so really the 3 tiers offer you different availability. S3 is really for your hot data, which you want to frequently interact with. Infrequent access is better for data that you may not need to access very often, but when you do, you don't want to wait for it. You want to have immediate access to that data. And then Glacier is for your colder archival data, data that you probably won't need to access very frequently. And if you do need to get it back, you can wait for a couple of hours. And as you move through the tiers, the cost goes down. And so you can take the right choice of storage tier to meet your particular use case. We also have the import-export Snowball. This is great for moving large amounts of data into AWS. So if you have many terabytes or even petabytes of data, AWS can ship you one of these devices. It will arrive on your network, in your data center, and then you can begin doing a very fast local data transfer to that device. The device encrypts all of the data with 256-bit AES encryption, and you can track that device as it leaves your data center and travels through the carrier to AWS. And then AWS will load that data directly into your S3 bucket where you'll have access to it. So if you're managing multiple petabytes of data upload, this is a great service to get you going. The other cool thing is it's very rugged. We did a demo where you can pick it up and just drop it onto the floor, so it can survive the calamities of carrier. So this particular customer was using Commvault backup software, which was very convenient because Commvault has native integration with S3. So we were able to very seamlessly retarget their backups to an S3 bucket in their account and begin backing up all of their data directly to S3 over the internet. And we built some lifecycle policies so that as they're going, they can start tiering data down to lower cost storage over time. I also want to talk to you today about the storage gateway, because I think this has a great use case for hybrid cloud. So the storage gateway is a virtual appliance. It gets deployed on Hyper-V or VMware in your own data center. And it creates a logical drive or a logical volume with an iSCSI target. So we have 3 modes of this. One is stored, which means that you have a one-to-one relationship between the storage on the logical storage that's represented with the storage on your SAN. Cached mode reduces the footprint of storage you need to have on-prem and keeps your hot data locally on that storage, but then tiers everything else, all the cold data, off to S3. And then the virtual tape library mode, or VTL, is for use with your backup software as a replacement for tape. So I'm sure everybody here loves managing tapes, keeping tapes in your environment, having to swap them in and out, call to get them back when you need one for recovery. So the virtual tape library really simplifies that entire workflow. And of course, all of the storage from the storage gateway is backed by S3. So you're gaining the durability of that 11 nines of durability. So in this case, this is what this looks like. You have a storage gateway in cache mode running inside of your data center with an iSCSI target presented back to your file server, and then you can reduce the amount of SAN storage you would need locally. This wasn't really an issue for this customer, but I presented it as options when you're putting together your migration strategy. So we didn't do this, but it was definitely an option they could have taken advantage of. Pardon me. So now that we've got a backup of all of the customer's data, and we understand how we're going to manage identities, the next thing to do is make sure we have connectivity between their data center and the AWS network. So networking is extremely important. This becomes your conduit to get data back and forth. So the first service that AWS offers, and really the core, is the VPC. This is your virtual private cloud. You can think of this as your own virtual data center running inside of AWS. It's really a logical isolation of all of your resources, and it contains a lot of the same networking constructs that you would expect to see in your own data center. So you have the ability to create subnets, you have the ability to create network ACLs, route tables, and even stateful firewalls. We call them security groups. You can extend your IP scheme into the VPC so that it's consistent with your existing CIDR ranges that you're using on your own network. Really, there's 3 different ways to connect to that VPC from your own network. One is over the internet using a proxy or a bastion host. More commonly, customers choose to use a VPN, a hardware-based VPN, or a Direct Connect. In this particular case, this customer chose to use a Direct Connect. So a Direct Connect is a dedicated network connection between your network and AWS and your VPC. It gives you that consistent networking performance, and we can deliver this in speeds of 50 megabits all the way up to 10 gigabits per second. And you can have multiple pathways, so you can have redundancy in case there's a failure. So now we're starting to build an architecture. We have the existing customer environment, we have the network connectivity, and we have a VPC. So that's great, but we need to do something with this. We just have all of this underlying infrastructure. Now we need to start layering in compute. So EC2, our Elastic Compute Cloud, is our virtual servers running inside of AWS. We give you the keys. You're in control. You can spin up new servers and destroy servers, delete them as your needs dictate. And it's flexible. You can choose to have a very small server, one CPU or a couple of gigabytes of memory. And you can go to very large servers, hundreds of CPUs. So you have a lot of range in the complement of hardware that you're able to take advantage of. And not only that, but you can change your instance type as your needs change. So if you start a server that's very small and use that for testing, and then as the demand and the usage of that server increases over time, you can change out the underlying hardware to give you more performance. The service is also delivered using standard operating systems, so Windows Server, as well as various flavors of Linux. So and we have a number of different versions of Windows, so there's some backwards compatibility as well. So the customer's very excited now, right? They see all this infrastructure, they're ready to go. Let's pick up that file server and just hand it to us. Okay, AWS, you take that file server, you're off and running. Well, number one, we can't take their file server, but we can import a virtual machine. So we could take that virtual file server running on-premise, and then we can move it and import it into AWS. And so that would look like this, right? Boom, move the file server over. You have network connectivity. Your clients can connect to that file server. Everything works just fine. However, there's a gotcha. Windows SMB is extremely sensitive to latency. And so while this would probably work, you may end up introducing some poor performance and a poor experience for your customers. And we don't want to do that. And so the solutions architects understand some of these constraints. And so we make recommendations that say, hey, for this particular use case, that may work fine, where you have maybe 1 or 2 users, and you're just using that as a backup target. But in this particular case, they had a lot of users who were accessing that file server, and we were concerned that they would have a poor performance, and we didn't want to set them up for failure. So we said, okay, that's great, but stop. Please don't do that. We have a different design pattern that will work better for your use case. And so this design pattern gives the customer a couple of things. Number one, and really the most important, it gives them high availability. So if there's a failure from their on-premises data center, there's a fire, they had a hardware failure, they'd have to recover those servers. And everyone has different disaster recovery plans, but sometimes disaster recovery plans can take hours, days to implement. And they're expensive if you want to shorten that time frame. So in this particular case, what we're recommending is the customer make a copy of their Active Directory domain controller and run it inside of AWS. So now they have 2, and they can replicate those together so they have an extension of their on-premises Active Directory network. Now they have Active Directory running both on-premises and in AWS. And then we can join the AWS directory service to that so that we have access to join other servers to the domain and leverage that directory for single sign-on to the AWS resources. So next, we add on and layer on a file server. This is a Windows 2012 file server looking just like the file server running on-prem in their data center. And then we configure DFS replication. And that's really the magic sauce. And I say magic sauce, but it's built into Windows. So when you're running a file server, you add a new role, and you can point your existing file server at the new one. And they will begin replicating. All of the data from the local data center file server will replicate to the file server running inside of AWS, and they will keep themselves in sync. So changes made on one side will always be reflected on the other. Now, the value of this is that while your users can connect to the local file server, they're not connecting across that link to the other file server. And so the latency between those servers can be a little bit higher, but DFS kind of mitigates that for you because it's not going to impact the direct end user during that synchronization. So what I'd like to show you next is building this entire environment inside of AWS. So I have a lab set up with VMware and a domain controller and a file server, looking just like this entire use case. From the lab, we have a direct connect into AWS, and then we're going to begin creating an Active Directory server, a file server, and configure DFS replication, and show you that entire process happening. So just a little bit of information before I get started with the demo. I threw some names up there because the demo is on a screen that's moving a lot. I had to zoom in to get you so you could see a lot of the text. So this is the name of some of the servers. You can see we've got, and I can't get that to work, so I won't. But we have the on-prem things named DFS-R dash file server domain controller, and then everything inside of AWS has a dash VPC. So you can see our VMware vCenter. That's our domain controller with 2 CPUs and 6 gigs of memory. And our file server, the same complement of hardware. They're all running Windows 2012. So I'm going to switch over now to the AWS console, and I'm going to launch a new instance. And this first instance will be our domain controller. So I'll select Windows 2012 from the dropdown. Hopefully you can see that. And now I'm going to choose an M4 large, which is the closest instance size to our on-prem, 2 CPUs and 8 gigs of memory. I'm going to make sure I choose the right VPC that has the connectivity with my Direct Connect, and then make sure that it's in the right subnet. And then there's the storage, the volume for the server itself. And now I'm going to make sure I name that server appropriately. Now the server is going to spin up, and we're going to fast forward a little bit so that we're not waiting for the server to get created. It takes about 5 minutes or so for an instance to spin up, and you have access to it. So now I've grabbed the IP address of that server, and I'm going to remote desktop to that server and begin configuring it. First, we need to install the Active Directory domain services roles so that it can join the existing Vegas Corp Active Directory domain. Once those roles are installed, then I can actually join it to the existing domain. So I'm going to fast forward some of this. Now the server's joined to the domain, and now we want to configure the AD connector. So that's the required information to connect that to the Active Directory. We're going to spin up that resource in the background. So now that the AD connector is there, we can create the next server, the next instance for our file server, and we can seamlessly join that to the Active Directory. Here's some details about the connector as we're spinning it up. And you can see I have not configured this yet for console access. We'll do that later. So we'll switch back over to EC2 and begin creating our file server. So again, we're going to launch an instance. We're going to choose Windows 2012 to match the stuff on our VMware side. Choose again an M4 large. And this time, after we choose the VPC, we're going to choose the domain join directory of Vegas Corp, which exists because of our AD connector. Same thing, we'll have to choose how much local storage we want to make available, and then name the server appropriately. So now that that server is joined to the domain, I can log in with my Active Directory credentials from my local AD into that server. So we're going to remote desktop over to that server and connect and start configuring that for DFS. So So again, now we're able to use the administrative account from my local AD to log into that server as a domain admin. Now we're going to begin first by creating a local volume on the server that'll hold the file shares. So all the files will get replicated from the other's file server to this one and get stored in this directory. Next, we're going to begin installing the DFS roles under the File and Storage Services options there. We have DFS namespaces and DFS replication are the two roles we need to install. So we'll click Next and then fast forward through this installation process. And now that that's installed, now we can begin configuring DFS through the console. So first we need to choose the first server that will host the namespace. This is the root share. So we're going to choose this file server and then create the namespace. For this, I'm going to choose reinvent. I'm also going to set some file permissions so that I have access to the share once it's created, and create the share. Next, I need to add the second server, the one that's in our VMware side. We need to add that to the namespace so they both participate and they both can respond to that same file server location. Now that we've created the namespace, the name that both servers will respond to, now we need to create a folder that will hold all of our data. That folder is going to reference the individual file servers and the locations of that data on each one. So I'm going to type in the location here of that corporate share folder, and then add the on-premises directory as well. Now that both servers are responding to the namespace, we need to make sure that they're replicating the data back and forth. We have the option of selecting a primary, and that's where the source of all of the data will come from. So in this case, we're going to choose the file server from our on-premises data center, so that that is the source of truth, and it will replicate all of that data over to AWS. If you had a large amount of data, you could leverage the import-export Snowball to precede that data, and then you could turn that off and just have it synchronize at the end. So you can see here quickly that the files start showing up pretty shortly after we set up the replication, and now the file server on the left is, or the window on the left is the file server on our premises, and the one on the right is inside of AWS. So now both file servers are in sync. So what if we now took that same concept of the storage gateway and put that into AWS? Our customer said, you know, I really love this whole thing, but I'm really cost conscious. We need to make sure that we're really reducing cost as much as possible. And I'm concerned about just making sure that everything is working correctly. So we introduced the concept of putting the storage gateway inside of the VPC. Again, we can put this in cached mode, so we're only leveraging a small amount of SSD storage on the instance, and then pushing the rest of that storage up to S3. There's some trade-offs here that you have to be aware of. So we're going to reduce cost by switching from SSD to S3. And we're going to increase durability. However, there's a trade-off in performance. And so it has to be the right use case. So if this file server has lots of large files, and a lot of the files are cold and won't be accessed very frequently, you can still get very good experience through the storage gateway. However, if you're expecting a lot of really high I/O, you probably want to keep that storage on SSD to get the performance. So it really, again, comes back to the use case, and that's where the solutions architects really help with this. We can help talk through the use case that you have, understand what your requirements are, and make suggestions about how we can optimize your environment given the different tooling that are available. So in this particular case, the customer chose to leverage the storage gateway, which had a significant cost savings for them. So for their 20 terabyte file server, on the left-hand side here, you can see that the storage cost for EBS storage was about $2,000. So their overall cost for running that file server and storage was $2,362. However, by introducing the storage gateway and tiering a lot of that storage off to S3, they were able to lower their costs to about $1,300. So that's a significant savings. Now I'm giving you these numbers as illustrative purposes because some of this changes, right? There's variation with the amount of storage consumed. You can also leverage our reserved instances for pricing to reduce some of that cost. So this is all our on-demand pricing. But I wanted to give you an example of what that savings could look like for a 20 terabyte file server. So next we wanted to tackle the BYOD challenge. The customer says, okay, it's great, we've got this file server running inside of AWS, but we still need to be able to access it. So our customers that are working from home or traveling, road warriors, need to be able to connect to that file server. So we leverage the Workspaces service. Workspaces is a persistent Windows desktop running in the cloud. It's Windows Desktop as a Service, so it's completely managed. You can click a button and spin up a virtual server pretty easily. And we have clients that support Mac, Windows, iOS, Android, and even a new web-based client. So now that we've layered in Workspaces, now the customer's end users have choice. They can work from their desk, and they can connect to their local desktop and then the file server on premises, or they can work from home using a virtual desktop and connect to the file server running in the cloud. This customer is now also insulated from hardware failures from their own network, or if they had a disease breakout and they had to close down because of the bird flu. They could shut their offices for a couple of days and all of their employees could still work from home. Not only that, but they could spin up new workspaces very quickly. So if they wanted to go from a couple of remote users to their entire user base, they could do that within a few minutes. So this is their environment. And I'd like to show you now layering on the last piece, which is creating that workspace and then making changes to your data in the cloud and having that reflected on premises, and then making changes to your data on premises and having it reflected in the cloud. So first, we're going to create an Amazon workspace. The first step is to register the directory, the AD connector that we've already created, with the Workspaces service. So we're going to do that now. And now that we've registered that directory, we can leverage that for sign-on. So our users that are existing in the Active Directory can be used to authenticate into the Workspaces service. So next, I'm going to actually create a workspace. I need to identify the user. In this case, it's me, Jay Butler, and selecting that from my Active Directory. And then I'm going to create that workspace for me. There's a one-to-one mapping of workspace to user. So each user is getting their own virtual workspace. We have two options. We have always on, and then we have hourly. In this case, because I was doing this for a demo and I wanted to be frugal, I chose the hourly option because I was only going to run it for a couple of hours. But for those users who are using the workspace very infrequently, the hourly option is a very cost-effective way to do that. For those users who are using their workspace all of the time, the standard version is better. So now we can see here my workspace is spun up and is ready for use. Again, we did a little bit of fast forwarding to save time. So I'm going to grab this registration code, which would actually get emailed out to me if my email address was registered in Active Directory. And I'm going to use that registration code to connect to my Workspaces client. I'm going to paste that registration code in there. And then the workspace is going to challenge me for my username and password to authenticate. So this is my jbutler user from my on-premises Active Directory and my password. And now I'm going to log into that workspace. What I did before this, and I didn't show you in the demo, is I actually set up a home directory in Active Directory mapped to this namespace. So when I log into this workspace, you're going to see this auto-mapped, my home directory. It's using that reinvent corporate share path, and there's nothing in there yet. So I want to create a new file, just a standard text file, pretty easy. But it could be all of my data already stored in there if I had data on premises. So I'm going to open up this file and add some text to it so you can see it, which is my thank you reinvent. Then I'm going to save this file, and in the background, DFS is going to replicate that file back to my on-premises file server. So let's close this out, and then I'm going to zoom out, and we're going to kick over to VMware and connect to our local file server, where I can look at the file server, local storage on C, corporate share, and there's a jbutler folder inside there. And now I can open that up, and you'll see the file exists there. So now I can make changes to that file from the local file server or from a local Windows client that was connected to it, and those changes will get replicated back up to AWS. So we'll switch back over to our workspace. And there's the file. So all of that's happening in the background, making the service very robust, resilient, and highly available for the customer. So this is what their environment looks like. They're very excited. They're happy. They have a hybrid environment. It meets a lot of their use cases. It's highly available. It can be scaled to meet their needs. So if they add a lot more users, they can increase the number of workspaces very quickly. If they all of a sudden have a lot more users show up, they need to scale up the hardware for their file server. They can do that during a scheduled downtime, and within 5 minutes, change out the underlying hardware. And all of the data is kept in sync. So this is great, but what does it cost? So this entire environment is about $6,000 a month using on-demand pricing. So that's your worst case scenario. And as a solutions architect, we typically tell our customers, start with on-demand, because you need to get an understanding of your usage and your customer's usage as you're working with these services. And then once you're comfortable that you have the right amount of hardware, the right complement of services configured, then you can get reserved instances to lower your cost. The real value here is that we often over-provision. I'm guilty of it. I used to throw a lot of hardware at a problem and never tested thoroughly. And so with AWS, you have the ability to really hone in on the right amount of hardware to solve the problem. And so if you can go from a server that has 16 CPUs down to a server that has 4 CPUs, you have significant cost savings. And you'll only know that by spinning up the environment inside of AWS and testing it. So while that was where they're at, that's not the end of the story. So if the customer at some point has completely amortized their investment in their on-premises data center and they no longer want to purchase hardware, they can at some point in the future choose to go all into AWS. Now again, this is not an all or nothing decision. So they have choices along the way. But for some folks, getting out of that really expensive colo facility is a driver. And so in that case, we can take the same exact design pattern and extend it from on-premises to cloud to multi-AZ in the cloud. And that way you still get the benefits of highly available architecture, but everything will be running cloud native. So in addition to all of the services that I've talked about so far today that this customer used, there's a number of other services that really could be used for hybrid cloud. And I invite you to take a look at some of these. And a few of them will be covered in subsequent sessions throughout this week. So I do invite you to take a look at them because they really have some great use cases around those different services. And with that, I want to thank you all very much for your joining me today. Thank you for coming to reInvent. I do appreciate you showing up and putting on a smile and bearing with me through this presentation. And with that, please remember to complete your evaluations. We do take a lot of customer feedback, and we really appreciate your input, and so that's important. I also want to let you know that we at AWS work in teams, and so this presentation was not just my own work, but the work of a lot of my colleagues that really contributed, including Brad Dispenza and Brian Tracy from my team, who really helped out to make this successful. So I wanted to give a shout out to them as well. Thank you all very much for your time today, and have a wonderful conference.